My best wishes to all the viewers. Welcome back to DTE Studio, Directorate of Technical Education in Karnataka. I am going to discuss in this class trigonometrical leveling. Trigonometrical leveling, it is prescribed, surveying 2, prescribed by the Board of Technical Examinations, Technical Examination Board. Now, in the previous class, I have given the introduction about the trigonometrical leveling. Now, I will continue with that. Now, for 10 minutes, I will discuss the things whatever we have discussed in the previous class, and I will continue the subject. Now, we are handling with the trigonometrical leveling. Now, trigonometrical leveling, now it is a branch of surveying. It deals with calculating, it deals with determining the elevation, relative elevations and distances of the objects. The main object of this topic is to determine the elevation of the given objects, isn't it? The object we can reach to the object, but to measure the distance between the instrument station and the object, and also the objects which we are not able to reach. Now we will let us see one by one. And now for example, these are the objects. Now see, these are the towers. Now this tower, object 1. This is the another tower, object 2. Another tower, it is object 3. Now here, this is the instrument station. Now where we can reach the object base of the object. The base we can reach from the instrument station to the object. Now whereas in these two cases, object 2 and 3, we are not able to reach the object. Now therefore, there are so many methodologies available in determining the distances and elevations. Now mainly we are employing the trigonometrical functions. Now number of times we have discussed about it. Now we should know the basic trigonometrical functions. Now in this subject, the main object again I will tell you, that is to determine the relative elevation. Now with respect to the benchmarks. Now what is the elevation of this point and what is the elevation of this object? Now here, and the elevation of this object. Now here we can categorize this in two ways. The one is where we can reach the base of the object. Now it is accessible object, and with the other two, object 2 and 3, we cannot reach the object from the instrument station. It is categorized in two ways. One is the base of the object can be reached. The other one is the base of the object cannot be reached, not accessible. Isn't it? So therefore, now see the instrument, the instrument used in this process or in determining the elevation is mainly, that is theodolite, tape and chain. And the trigonometrical function, basic trigonometrical function, sin theta, cos theta, tan theta, and inverse functions, and also sine rule and cos rule. We should have the thorough knowledge about this. And the terminologies which are used here. Now let us understand this. Now see, this is object 1, object 2, object 3. Now this is the instrument station. This is the instrument installed, and the instrument is level. The line of sight is horizontal. Now this is the horizontal line of sight. And these two are the inclined sights. Inclined sights that is bisected to the object 3 and bisected to the object 2. In the similar way, we can measure the angle to the object 1 also. Now from here to here, we can measure it. Now that is vertical angles. Now, so here this is the vertical angle, and this is the vertical angle. This is the vertical angle to the object 3, and this is the vertical angle to the object 1, and also we can measure the vertical angle to the object, isn't it, from the instrument station. Okay, and now please understand the height of the object above the instrument axis. Now always remember this. Height, H means H is designated. H is designated as, now see, H. This H is designated as the height of the object above the instrument axis. Please remember this. Height means it is not the height of the object. Now please remember, it is the elevation of the object above the instrument axis. With respect to the instrument axis, the heights are measured. Now this is the height of the second object, and this is the height of the first object above the instrument axis. And you know, already I told you that this can be categorized into, that is, base of the object accessible and base of the object inaccessible. Now, base of the object inaccessible, now it is in the single plane. Now these two are in the single plane, and this is in the different plane, double plane method. These two are in the single plane method, same vertical plane, and this is in the double plane method. Now we will discuss one by one slowly. Okay. Then see the case one, when base of the object is accessible. Now see, very simple. Install the instrument near the object where we need to calculate the height, elevation of the object, elevation of the given object. So therefore, install the instrument and measure the distance from base of the instrument to the instrument space, the object, that is horizontal distance d, and also measure the vertical angle. Now this is the height of the object above the instrument axis. Now therefore h, this is h. Now this is alpha. It is simple method, very simple method. Now there is no issue with that. Now therefore see, now this is diagram. Now this diagram is available in the textbook. Now whereas this is the practically taken from the field. Now therefore you please remember. Now very simple. Now this is height of the object above the instrument axis, and this is the vertical angle measured alpha. Now therefore this is the distance is also measured from the instrument station to the object. Now after doing this, now simple. See, now this h is equal to, now considering this triangle, that is AOQ dash. Considering this triangle, now this is opposite side. Now this is adjacent side. Now therefore h is equal to d tan alpha. Now when this height is calculated above the instrument axis, now this is the staff reading taken when the line of sight is horizontal above the benchmark. Now the elevation of this object is equal to, elevation of q is equal to, that is now benchmark, the value of the benchmark, plus instrument staff reading, plus h. Now that is simple problem, simple analysis. Now sometimes it will be asked for a problem, and also sometimes it will be asked to explain how to measure that is elevation of the given object when the base of the object is accessible. Now this is how we can measure it. And similarly, when the base of the object is not able to access, not possible to reach the base. Now this is one example we have taken now to explain, to understand more. Now see here, now this is when it is not possible to reach the base. When it is not possible to reach the base, then we will apply this method, this kind. So that is, now here the second case, base of the object is inaccessible. We are unable to reach the base of the object, isn't it? Therefore, now in here, the simple method, first install the instrument at one station, that is near the object. Now this is, say, let us assume that it is station A, station 1, and measure the vertical angle. Now perform all temporal adjustments. You know all those things. When you are using the instrument and measuring the vertical angle, now you must write the procedure, isn't it? From the examination point of view, you must write the procedure, and also we should know. Now install the instrument, level carefully, and make the line of sight horizontal truly, or make the line of sight horizontal, and take a back sight, isn't it? Take a back sight or stop reading on the benchmark. Then rotate the telescope and bisect the object Q, where we need to calculate the elevation of the given object. Then measure this vertical angle. Now measure the vertical angle by changing the phase. Now Now, by making the face of the instrument left face and by then change the face of the instrument to the right side, then measure the vertical angle. Measure the vertical angle. We will get 4 readings. So when the face of the instrument is left side, we will get the value for vertical angle C and D. And also when change the face, then measure the vertical angle, we will get 2 more readings, that is C and D. Isn't that? C and D, then we will get the 4 vertical angles, make the average of that will give us the value of the alpha. Isn't that? Alpha 1. And similarly, then at a known distance, that is usually it is 1 chain length, not necessarily be 1 chain length. Normally, when we are discussing about the topic and subject, we describe 1 chain length. No, it is not necessary at all. Now, depending upon the convenience, now where you are measuring where you are conducting this experiment, or where you are measuring the elevation. Now, based on that, now the space available, the instrument with you, now you decide the distance between the first instrument station and the second instrument station. Now this is designated as B. Now here, then shift the instrument to the station D. Now here I would like to say one important thing here. Now see, now this is the instrument object, then first instrument station, second instrument station. Now they are in one line in the vertical plane. See, for example, now I will tell you like this. Now first install the instrument and make level the instrument perfectly. Then make the line of sight horizontal. Then take the back side on the benchmark, stop reading, then measure the vertical angle. Done. The first job we have done it. Now how many data we have now? One stop reading we have, the other one is vertical angle we have measured. Right? Understood? Got it? Then what we should do? Locate a second station, instrument station. Station 1 and station 2, isn't it? Then just transit the telescope and go back and install the instrument to the station 2, isn't it? That is station 1, this is the station 2, isn't it? And repeat the process, isn't it? Repeat the process, then make the instrument level the instrument perfectly and make the line of sight horizontal, then take the back side on the benchmark, then measure the vertical angle, isn't it? Now please note, now the instrument station 2, instrument station 1 and the object. Now these 3 are in one single plane, isn't it? Now this is called single plane method. Got it? Understood? Instrument station 2, then object. Instrument station 2, instrument station 1 and the object. All the 3 are in the same vertical plane. Therefore, it is called single plane method. Okay? Understood? Isn't it? Now we have data that is the data alpha 1 and alpha 2 and yes, isn't it? And also we have the data distance between the station 1 and station 2, isn't it? Now therefore we have 4 data. Now this is one method of calculating the elevation of the object Q. Now here you please note down. Now consider this triangle. Now this triangle. Consider this triangle. Now considering this triangle, that is QA Q dash. Now H is equal to what's happening now? D tan alpha 1. H is equal to D tan alpha 1. But whereas here H is not known, we need to calculate, and D is also not known, we need to calculate. No, we have only a data alpha 1, isn't it? We have one equation and 2 unknowns. One equation, that is H is equal to D tan alpha 1. D tan alpha 1. By considering this triangle. Now this is the triangle. By considering this Q and A Q dash, isn't it? Considering the triangle, H is equal to it is d tan alpha 1. Similarly, consider the triangle, another triangle, that is Q, B and Q dash. That is also another triangle. Now but the angle is alpha 2. Now here what happens now? By considering this, now this second triangle, that is H is equal to, H is same for both, isn't it? In both the station H remains same. Now therefore, that is alpha 2. Considering the second triangle, this triangle, that is Q, B, Q dash. Now H is equal to, what's happening now? H is equal to D plus B tan alpha. D plus B tan alpha, isn't it? H plus D plus B into tan alpha, isn't it? Now we have two equations. That is, one is H is equal to D tan alpha, and with this by considering this triangle, and similarly by considering another triangle, that is H is equal to B plus D tan alpha. We have two equations, and there are two unknowns now. From the equation, we have H we don't know, and D is not known, alpha is known, alpha 2 is known, and B is also known, isn't it? Now we have two equations, two unknowns, and three known data. From this we can calculate, now equate H is equal to, H is same for the both the triangles. So therefore H is equal for both the triangles, that is Q A Q dash and also Q B Q dash, isn't it? H is same for both the triangles, but only thing, this distance. Now for the first triangle, now for this first triangle alpha 1, now this is D tan alpha 1. But for the second triangle, B plus D tan alpha 2, isn't it? Now equating them, now we can calculate it. See, now this is the triangle, first triangle D tan alpha 1, second triangle H is equal to B plus D tan alpha, isn't it? Tan alpha 2. And when equating these two, we will get, after simplifying this, we are going to get D is equal to B tan alpha 2 divided by, then our problem is solved, isn't it? When once we calculated the D, when we get this D, now the other things can be, H can be solved, isn't it? Now apply this triangle, H is equal to D tan alpha. Then D is calculated from this, then H we are going to get it, isn't it? After calculating the height above the instrument axis, now we can calculate the elevation of Q. To calculate the elevation of Q, now benchmark plus stop reading plus H. Our problem is done, isn't it? We have completed the problem, isn't it? Now our object here is to calculate the elevation of the given object, isn't it? Elevation of the object, elevation of the point Q, isn't it? Therefore, this is one methodology applied to calculate the distance and elevation. Now we have calculated the other distance also, D calculated, and also elevation is also calculated, isn't it? Now see, in practically, now to get this situation is little difficult. Do you know about it? Now is it easy to get this situation? To make both the station, that is station 1 and station 2, the line of sight can be made in the same line? Is it okay? Can you do it? No, it needs more time. You can do it, isn't it? But it needs more time, isn't it? Now therefore, now let us see what to do next. Suppose if you have time, morning to evening, you can carry out this, no issue. You can do it. Once you make by trial and error, this can be easily, we can do this. To get this same level, the second instrument station, little time, you have to apply the trial and error method. Once it will go and then come down, then go, then come, like many number of exercises you need to do it, isn't it? Now it is practically a little bit difficult to do it, achieve this. Therefore, now let us see. Therefore, what next we have? Now see. Now this is more simplest method to achieve this. The same procedure, whatever the thing, whatever we have discussed in the previous method, the same thing we have to follow here. The only thing here is that is instrument stations are at the different level. Instrument stations are at different level. The first one, see when the instrument station is first station, now install this instrument near the object, then perform all the duties, that is temporary adjustments, then make the line of sight horizontal, then take a back side, that is S1 side, that is stop reading S1, and similarly that is then after measure the vertical angle. This is alpha 1, this is S1. Now we have two data, isn't it? Then what we should do next? Shift the instrument station to the second station. Shift the instrument station to the second station. It is at a known distance. Known distance, that is at the distance B. Isn't it? Shift the instrument to the second station, then repeat the procedure, then measure this node backside, take a backside on the bench one, that is stop reading, that is S2. It is S2, stop reading, then measure the vertical angle. Isn't it? Vertical angle. See, after doing this, now let us consider this triangle. Now, if you consider this triangle, see here, the first triangle, Q dash. Considering this triangle, H1 can be, an equation can be formed. H1 is equal to what again? H1 is equal to again D into tan alpha 1. H1 is equal to D into tan alpha 1. Isn't it? Then first problem we have solved. Right? And H2 is equal to again D plus B tan alpha 2. Now our problem starts. Isn't it? Now there are all unknowns. Now here, if you consider this triangle, first triangle, now here H1 is unknown, D is also unknown. Isn't it? H1 unknown, D is also unknown. There are two unknowns, one equation is not possible to solve that equation. Now, by considering the second triangle, that is here, that is QB, Q double dash. Now again, H2 is unknown, D is unknown, isn't it? Then B is known, alpha 2 is known. Now here, now we have two equations, but there are three unknowns. H1 is unknown, H2 is unknown, isn't it? Understood? And also, D is also unknown. There are three unknowns, we have two equations. Now therefore, it is difficult to solve the problem. Now therefore, what we have done, see now, this line of sight, the line of sight here, in the second instrument station, it is projected here. It is projected, isn't it? The line of sight in the second station is projected to the first line of sight, isn't it? Horizontal line. First instrument station horizontal line. Then see what is this distance? Now from here to here, that is the difference of stop reading. The difference of stop reading. Difference of stop reading. It is difference of stop reading S2 minus S1. Now therefore, that is known, no? It is known. And alpha 2 is also known. We have calculated. We have measured. Isn't it? Then alpha 2 is known and this distance is known. Now consider this triangle. Now consider this triangle. That is B2, B dash, B1. Consider this triangle. Now by considering this triangle, solve this triangle. Now let us find out the distance between B and B2, B dash and B2. Now let us calculate the distance. This distance between. Now by considering this triangle, now calculate the distance. This is this distance. We know the S2 minus S1. The difference in two stop reading, we know this. And alpha is known, isn't it? Now this is alpha 2 is known. Therefore, now let us solve this problem. We will get the distance between this and the B and B dash, B2 and B dash. Isn't it? Now, if you now just we are modifying our triangle to make the procedure simple. To make the procedure simple and to make the problem solve the problem easily, now we are modifying this. Now after doing this, after calculating this distance between these 2 points, that is now consider that another triangle, one more triangle. Now this triangle, that is Q, B1 and Q dash. Now let us consider this triangle. By considering this triangle, now what is happening now? H1. Now already we have H1. H1 is equal to D tan alpha 1. Already we have D tan alpha 1. Now therefore, now considering this triangle, now what is going to happen now? Now here the second triangle of modified triangle, H1 is equal to D plus B plus from here to here. Isn't it? Now after solving this problem, now let us see what we are going to get it. We'll see. See, now that is the first triangle, considering this, the first triangle, considering this triangle, it is D is equal to, consider H1 is equal to, it is D tan alpha 1. H1 is equal to D tan alpha 1. H1 is equal to D tan alpha 1. Then consider the modified triangle, the second one, it is. After considering this modified triangle, now let us see what we are going to get it. Isn't that? Now see. Yeah. Now this is the modified triangle, that is Q, B dash and Q dash. Considering this triangle, now what is going to happen now? That is H2 is equal to, H2 becomes what? From here, that is H. Yes. Yeah. See, in the modified triangle, now this is Q, B1 and Q dash. In this triangle, H1 is equal to this length, base of the triangle, D plus B plus B plus. Now this is the distance from here to here. Now thus by solving this triangle, we are going to get, that is S cot alpha 2. S cot alpha 2. The distance between, that is B2 and B dash. B2 and B dash is equal to S cot alpha 2. Now therefore, now to solve the second triangle, that is Q, B1 and Q dash, D plus B plus S cot alpha 2. Now that means what I mean to say, the B is increased by S cot alpha 2. S cot alpha 2. Isn't that? Now therefore, now both this triangle H1, this triangle that is also H1. Now H1 is same in both the triangle. Now equate those two. Now we are going to get what? Now see, we will get. Now this is the equation we are going to get. D is equal to B plus. Yes. Isn't that? B is equal to, D is equal to, yeah, B plus S cot alpha 2 multiplied by tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Isn't that? So this is what we are going to get it. D is equal to. Okay. So similarly, now in this case, The farthest instrument station is above the axis, instrument axis is above the nearest instrument axis, isn't it? Now here the instrument axis, nearest instrument axis lower, and the farthest instrument axis is higher. In the second case, now this situation is also possible. We are going to get it here. Here the station 2 is higher, and in the second case the station 2 is lower. Now what is happening here? See, now here in this case B remains same. Now this B is going to reduce. Now the triangle is modified. Consider this triangle. Now this triangle and find out H1. Find out H1. H1 is equal to H1 becomes what? D into tan alpha 1. Isn't that? Now then modify this triangle. Now just project this. Now from here, drop this from here. Yeah, just draw this line from this junction and then calculate this distance. To calculate this distance, now see, now this is S1 minus S2, that is difference between the stop reading, yes, and then this is alpha 2. This S is known, alpha 2 is known, so we can calculate the distance. Now this distance becomes again, that is S cot alpha 2, S cot alpha 2. Solve this triangle. By solving this triangle, that is tan theta is equal to, you will get the value. Now, yes, now this distance B2 is equal to B2 is equal to S cot alpha 2, isn't it? Now B2 is equal to S cot alpha. S is known, difference between the stop reading. Then alpha 2 is also known, isn't it? Now therefore, now here B, what is going to happen for B here? B becomes what here? B is reduced. In the previous case, B is increased. See, now this B is increased. Now what we have done? Now by considering this triangle, H1 is equal to D plus B plus S cot alpha 2, isn't it? Now therefore, in the next case, in the second case, now here this B is reduced by how much? B is reduced by S cot alpha 2. S cot alpha 2. Now this amount is reduced. Now therefore, consider this triangle, Q, V1, then Q1, H1 is equal to D B minus S cot alpha 2, isn't it? In the previous case, B is increased by S cot alpha 2. In this case, B is decreased by S cot alpha 2, isn't it? Then if you understand this, our problem is solved, isn't it? So therefore, see, we can see this. We can understand from this equation, isn't it? Now first consider this triangle, calculate H1. Then consider this triangle after modification. That is H1 is equal to, isn't it? Now in the second case, next case also, calculate the H1. Calculate H1 by considering this H1 is equal to D tan alpha 1. Then modify triangle after modifying, considering this triangle Q B1, that is Q1, isn't it? Therefore, H1 is equal to D plus B minus S cot alpha 2, isn't it? In one case, that is B is increased. In this case, B is decreased, reduced, isn't it? Therefore, it is B minus S cot alpha 2. In the previous case, B plus S cot alpha 2, B plus S cot alpha 2, B plus S cot alpha 2, and here in this case B minus S cot alpha 2. Then our problem is solved, isn't it? Now these are the three cases. Now this is really elaborated here, isn't it? Like whatever we have discussed now, Now this is very simple way it is written here, isn't that? C is equal to. Now here I think it is taken as H, that is S1, S2. There is some correction here, that is S1 and S2, and that is S. Now here C is equal to S. Now B dash C is equal to H. It is S cut alpha 2. Now this distance is S cut alpha 2, isn't it? Now therefore, now please note that is in one case, that is in one case B is decreased by S cut alpha 2. In another case, S is increased by, yeah, it may be in the next slide, isn't it? See here. Now here all the combination of the three. When instrument axes are same, now this becomes D is equal to B tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Isn't it? When this situation is little difficult to achieve it, so therefore, now this becomes the instrument axis are at different levels. Now then D is equal to B plus H2 H B plus S cot alpha 2 into tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Now here the B is increased. Now here if you consider this, the third case, now here B is reduced by S cot alpha 2, isn't it? Now if you understand this or these three situations, the other things will become simpler, isn't it? Now let us see. Now, yeah. Now this is another case. Now there is an object here. There is an object. We are unable to conduct the experiments like this. We are unable to have the situations like this. So therefore, no here. The instrument station is not in one. Instrument stations are not in one plane. Now already I told you that. When first instrument station, then elevated object, then instrument station 2, isn't it? Instrument station 2, instrument station 1, and the elevated object. All these three objects are in the same vertical plane. That is single plane method. Now here, in this case, the first instrument station is here. So here. This is the first instrument station, then elevated object is here, then move this to the second station, elevated second station, the elevated object is same, then it forms a triangle in the ground. One first station, second station, and the elevated object. Second station and the first station and the elevated object, isn't it? This forms a triangle. That you can see now. This forms the triangle. Now here, this is the first station, elevated object. That is one plane, isn't it? Instrument station and the elevated object, they are in one plane, isn't it? And the object is, the second instrument station is here, and the elevated object is this. This is another plane, vertical plane. Therefore, it is double plane method. Understood the difference between the single plane and double plane method? Got it? Now, instrument station, then on the same line, just transit the telescope, then fix a at a known distance, isn't it? Now, this is the second instrument station and the elevated object. All these three are in the same plane, vertical plane. It is single plane method. Double plane method, instrument station and the instrument station and the elevated object. Got it? One plane, instrument station and elevated object. Instrument station and elevated object. This is one plane and that is another plane. Understood? Isn't it? Now this forms a triangle in the ground. This is the station 1. This is the station 2. Now here also same thing. Install the instrument, level it carefully, then make the line of sight horizontal, then measure the vertical angle, and also identify the station 2, measure the horizontal angle, then shift the instrument to the next station, isn't it? Shift the instrument to the next station. Now again repeat the process. Find out, isn't it? Find out the, now make the line of sight horizontal, then measure the vertical angle that is alpha 2, then measure the horizontal angle, isn't it? In the triangle, in the ground. Isn't it? How many data we have now? That we have the distance between the first station and the second station, and we have theta 1 and theta 2, and we have that is alpha 1 and alpha 2, isn't it? So therefore, let us assume that it is D1, and from this instrument station to the object it is D2, and this is B, distance between the two instrument stations, isn't it? And this is H1 from the instrument station first one, and this is above the instrument axis H1, and from the second instrument station it is H2 above the instrument axis, isn't it? Now see, now this is the this diagram is available in the textbook, and this is the practical situation, isn't it? Now this forms the ground triangle in the first station, second station, and the elevated object, isn't it? Now measure this horizontal angle and measure this horizontal angle. Now this is theta 1 and this is theta 2. Theta 1, theta 1, theta 2, and see we can find out this angle, isn't it? 180 minus theta 1, theta 2. And we know the distance between the first station and the second station, isn't it? Then from first station, measure the vertical angle, no, isn't it? Measure the vertical angle, and from the second station, measure the vertical angle, isn't it? Now, then solve this triangle. Now, when you solve this triangle in the ground, theta 1 is known, theta 2 is known, and also theta 3 can be computed, isn't it? Theta 1 is measured, theta 2 is measured, and theta 3 can be computed. 180 minus theta 1, theta 2, isn't it? And measure the vertical angle from the first station, alpha 1, so this is alpha 1, and from the second station, measure the vertical angle, that is alpha 2. Our problem is solved, isn't it? Now we can find out the distance from the instrument station to the object, isn't it? We can find out the distance from the instrument station 2 to the. Now see, theta 1 is known, theta 2 is known, theta 3 can be computed, and this distance between the two stations is known. Then solve this triangle by applying sine rule. Isn't it? Now therefore, sin theta divided by length of the opposite side, then sin theta 2 divided by length of the opposite side is equal to, that is sin theta divided by opposite side. It is known, and solve those triangles to solve that sine rule. Now we will get the distance from the first station to the object, and similarly second station to the object. When we get this distance, now distance is known. Distance is known when the distance, the distance from the first instrument station to the object and this distance are same, isn't it? Right now calculate this H1, isn't it? Height above the instrument axis. Calculate the height above the instrument axis, isn't it? Right? Now after distance from the first instrument station to the object is D. Now therefore vertical angle is known. Therefore H1 can be computed. H1 is equal to D1 tan alpha 1. H2 is equal to H2 D2 tan alpha 2, isn't it? D1 is calculated by solving the triangle, this triangle. We have solved this triangle. Now by solving this triangle, we have calculated the distance D1 and distance D2. Now therefore, that is the H1 is equal to D1 tan alpha 1 and H2 is equal to D2 tan alpha 2. Now our problem is solved. See, now from here you have taken a benchmark. Yes, isn't it? Now that is staff reading. Staff reading is taken on the benchmark. Now from here, see, now the elevation of this object it can be calculated as benchmark plus staff reading, benchmark plus staff reading plus H1. Similarly, from this station, benchmark plus staff reading not shown here. So we can take the staff reading from the say another station also, isn't it? So therefore, to calculate the elevation of this Q, that is this object, benchmark plus S1 plus H1. Similarly, from this station, benchmark plus S2, then plus H2. That gives us the elevation of the object. Now, by solving this triangle, now we have calculated the distance from the instrument station to the object, distance from the instrument station, second instrument station to the object, and H1 and also H2. Whatever we want, we can calculate. We can calculate it in any way. We can apply. Not necessary to calculate both. No, only for check we can calculate the other also, isn't it? Only once if we find out the Q, elevation of this point is sufficient. Only for check we can apply from the second station also, isn't it? Okay. Now that is again the another example, that is how to calculate, how to find out the elevation of this object and elevation of this object, and then further, yeah. Now the procedure is explained here. Now what we have discussed so far, the procedure is written here. You just go through this. It is available in any textbook, and simple procedure, that is install the instrument, isn't it? Level it carefully and make the line of perform all temporary adjustments. Make the line of sight horizontal. Then take a back sight or the staff reading on the benchmark. Then rotate the telescope, check the object where you need to calculate the elevation of the given object. Then measure the vertical angle. Measure the vertical angle by changing the face of the instrument, isn't it? Understood? Shift the instrument to the second station. Repeat the process. Measure the vertical angle. Then solve the triangle in the ground. The procedure is written here. Okay? Understood? Then similarly, now that is I told you now, that is solve the triangle. That is how to the solving the triangle, that is sine rule. Isn't it? Applying the sine rule, and we can see I told you that is theta 1, theta 2, 180 minus theta 1, theta 2. Isn't it? You can go through this. Yeah. Okay. Then that is sine rule. It is calculating the distance d1, d2. We can calculate it, and also calculate the height of the instrument. We apply the simple method. Now, can we solve this problem? See, we'll discuss one or two three problems as much as we can learn. Let us see. Okay. Now let us see. Now there is a problem here. Normally, this kind of problems will be asked in the examination. Now see, a vane 4 meters above the foot of a staff was sighted at a point 2,000 meters from the instrument station. A vane 4 meters above the foot of a staff was sighted at a point 2,000 meters from the instrument station, isn't it? Away from the instrument station. The observed vertical angle is 2 degree 30 minutes. 2 degree 30 minutes, isn't it? The reduced level of the Trignometrical axis being the staff at the staff station is 100.75. That means the reduced level, RL of the Trunnion axis. Trunnion axis means horizontal axis, isn't it? Horizontal axis RL is given and vertical angle is given, and this vein is above the foot of, isn't it? 4 meter above the foot of the staff, isn't it? Understood? Now understand, have you understood this diagram? Now read the problem carefully and please understand this. Now our problem is solved, isn't it? Now see, Trunnion axis, horizontal axis. This is the horizontal axis. From this, the vertical angle measured is 2 degrees 30 minutes. 2 degrees 30 minutes. Okay? 2 degrees 30 minutes. Now it's a simple problem, isn't it? Now here it is 2000 meters away from the instrument station. Therefore, now this is D and this is H above the instrument axis. Very simple problem. Now therefore, now how do you calculate H? H is equal to D tan both are given, isn't it? Right now, there is no much problem in this, isn't it? Very simple problem and very simple solution. H is equal to D tan alpha. H is equal to D tan alpha, isn't it? Right now, substitute it. D tan alpha 2010 2 degree 30 minutes. Our problem is solved. 87.4 meter. So therefore, RL of this, RL, they have asked the RL of the foot, isn't it? So therefore, RL of the Trunnion axis plus H minus 4. Now therefore, the RL of this point is RL of the Trunnion axis plus H minus 4. That is RL of the Trunnion axis. Sorry, RL of the foot of the staff, isn't it? Got it? Understood? Yes. That is the only solution we have. Simplest. Only 2 minutes job. Okay? And there is one small problem is there. I will come back. Let us see. What is that? A small hitch is there. Yeah. Now see. Now this is the Earth surface. Have you gone through this? Have you understood this? This is the understood. This is the Earth surface. Earth surface you all see, isn't it? And see what is this line? Then it is the Earth surface. This is the Earth surface. No, it is called a level surface. A level surface is the surface which is parallel to Earth surface. Understood? Level surface. Level surface is a surface which is parallel to Earth surface. How many number of Earth surfaces are there? How many Earth surfaces? How many Earth surfaces are there? Sorry, level surfaces. Earth surface is only one, isn't it? Earth surface, which is parallel to, isn't it? Level surfaces. How many level surfaces are there? Any number which is parallel to Earth surface. This is one, you know. What is this? It is level surface, which is parallel to Earth surface. Understood? Got it? See, this is the Earth surface. This is the level surface. Suppose your instrument is little below, then level surface come down, you know. If your instrument is above, your level surface becomes above, isn't it? Right? Yes. Now therefore, we can draw any number of level surfaces. We can draw any number of level surface which is parallel to Earth surface, isn't it? Now, in practice, what we are going to do, we will do, we are make the line of sight truly horizontal. Now, this is the horizontal line. Now, all the developmental activity is taking place with respect to the Earth surface, no? Isn't it? Yes. Now, therefore, there is in the theory, in surveying theory, we have, there is some error, isn't it? No, this is the error. No, this is the error occurred in reading the soft reading, isn't it? Now, strictly speaking, we need to, we want this level, that is whatever the levels we take. No, we need, with respect to the earth surface. But our line of sight is truly horizontal. Our line of sight is horizontal. Therefore, we are going to do this much error in our work. Understood? Got my point? Now our developmental activity is taking place with respect to earth surface, but we are handling with the instrument which reads horizontal. Now, therefore, this is the error involved in our survey work, isn't it? This is the error involved. Therefore, now this error is called, that is curvature and refraction effect. We will say curvature and refraction effect. The curvature effect. Now, this is the curvature effect, isn't it? Now, therefore, now what we should do now, our stop reading must be reduce or increase. Now, we want with respect to our earth surface, we want the value for our with respect to earth surface, but we will get, we are reading with respect to this, isn't it? Now, therefore, this has to be reduced. Now, that effect is called curvature effect, curvature and refraction effect, or curvature and refraction effect, isn't it? When this will be considered? When the sides are too large, isn't it? Too long. When the sides are too long. Now, there is an equation available in the textbook. Now, if anybody wish to understand that, we can go through that. Now, see, 0.60673 d square. That is the curvature and refraction error, isn't it? Correction for curvature and refraction error is incorporated, isn't it? When this has to be applied. Now this d, this d is the distance from the instrument station to the object. Instrument station to the object. This is the distance. Now, when you apply this, when your d is in kilometer, you submit that and calculate it. The value comes, if the value is within third digit after the decimal, then you take that into account. Understood? For example, soft reading 2.375. 2.375 is the soft reading you are going to get it. Isn't it? Now, this error, after calculating this, you will get that depending upon the distance, no? Distance. You calculate the distance by applying the distance. If the value, this value 0.0001, will you consider that? Not necessary to consider that. That is, distance is too small, isn't it? If the value is 0.002, then we need to apply. Top reading should be reduced by 0.002, isn't it? Now, that means this figure itself shows that now the error is more when the distance is more, isn't it? When the distance is less, not necessary to take that into account, isn't it? Now, what does it mean now? Now, if you are reading the long distance readings, then you need to apply, when we want a precise values, even if you want a precise values, isn't it? For smaller distance, it is not applicable, but whereas in our problem, it is given, in our problem it is given, it is 2000 meters. Therefore, we will get some value for that, isn't it? Therefore, we have taken that into account, isn't it? Now, let us see what we have done it here. Now, see, that is calculated here. That is calculated, it is 2 kilometers, submitted in kilometer. Submitted in kilometer, and therefore 0.0673 d square, then the value of error, curvature and refraction error, then height of the shaft above, now what we have calculated, that is calculated. Now, that is H plus 0.27 we have taken this as, then RL of the staff weight is equal to this much, then calculate the RL of the station, isn't it? RL of the staff station is this 184. And please remember here, now this is, we have added, I told you that it should be deducted. It should be deducted from the staff reading. It should be added to the RL, isn't it? Understood? The curvature and refraction error must be deducted from the staff reading and should be added to the reduced level. Okay? Now this is, we can solve, this is the solution we have. Then there are many problems available. Let us see. Now for today I will stop it here. Thank you very much for all the participants. Thank you so much. Thank you all. Now again we are meeting on Wednesday at 11 o'clock. Thank you very much. Thank you all.